Welcome to making a Stuart model steam plant, part 76. Removing the parts from the baseboard and making a brass fitting to drain all of the water from the sump. What I need to do first in this episode is remove all of the parts from the baseboard, and I'm going to put all the parts, other than the engines, in this large plastic tub, so don't lose any of the parts. That would not be a good idea. In this clip I'm removing the Allen cap head bolts that are going to hold the clamps in place, and I've decided I'm going to paint these clamps. Brass as a metal looks really nice when it's polished, but polishing these brackets would be difficult, and the metal polish would go all over the black part of the boiler. I'm not going to paint the brass grate because that's going to be very easy to remove for cleaning. These two parts are now in the plastic box, so it's time to turn everything around and look at the other end of the boiler. This ceramic heat shield is not the one I'm going to be using, it's too small. I'll buy a larger piece and cut it to size. After the steam test, what I'm very interested in at the moment is whether the heat of the boiler damaged the baseboard, and thankfully it didn't. And the paint on the sides of the boiler didn't blister either. Mission accomplished with this one. I have in the past had problems with the heat of the boiler burning the baseboard. The next job is to remove the water pump and the other boiler mounting clamp. These parts will also be temporarily stored in the plastic tub. And the only part that won't be going into the tub is the mounting base for the 10V, because that is made from wood and it's painted and would get chipped. Fitting this hand pump was a pain, and removing it is also a pain. The brass nuts may look good in this application, but they are very close to the mechanism of the pump, and removing them was quite a fiddly job, but eventually everything was okay. Even though it's a tight fit on the studs, this part that I made comes off quite easily. This steam clamp will need to be partially dismantled for shipping to the USA. This clamp that I'm currently removing will be left fitted to the baseboard once it's been painted and the baseboard has been finished. The next part to go is the mounting plinth for the 10V. Nothing difficult here. The final thing to be removed from the baseboard is the Stuart S50 steam engine. It's temporarily held in place using 3 cheesehead 4BA bolts. The owner of the engine will have to do some assembly of the parts on the baseboard, and I'm going to supply him with a quantity of cheesehead 4BA bolts made from brass to avoid any rusting problem. Now the baseboard is devoid of any components other than the 4 studs for mounting the pump. The next job to look at is the outlet pipe from the sump. When this steam plant is completed, I don't want any parts permanently sticking out, and it's utterly pointless fitting a tap like this. It would have no function. What I need to do now is make a fitting to accept a piece of silicone rubber pipe that screws into this thread of the pipe inside the baseboard that leads to the primary drain area. The first part of the job is to turn across the front as shown here, followed by machining longitudinally. What's the final diameter going to be? I've really no idea, as long as my piece of silicone rubber pipe fits smoothly onto the end of it. What I'm doing at the moment is turning this part down to 5/16 of an inch in diameter, and then I'm going to thread this, and the thread will be 5/16 by 32 threads per inch. In this clip I'm setting the micrometer to 5/16 of an inch. I'm using a twist drill for this just because it's quicker than looking at the vernier. As a very general rule, twist drills are usually 1 thou less than the size you want, which means you do need to look at the vernier to add the 1 thou. This may not be good engineering practice, but it's always the way I do it. And the main thing is, it always works fine. And for any experts watching, this, by the way, is a metric micrometer, but as you can see, I still get the part to 5/16 of an inch. The next thing to do is center drill the middle of the work. I know you can't see this happening because the camera isn't mounted in the best place really, but when I remove the chuck you can clearly see the center hole. In this clip I'm using my tailstock die holder fitted with a 5/16 by 32 threads per inch die, and I'm turning the chuck by hand. A bit slow perhaps, but in no time at all a nice clean 5/16 by 32 threads per inch thread appears on the work. Now I need to drill a hole down the middle, and the hole has to be as big as I can possibly get it without the thread being weakened. To turn the other end, which will accept the silicone rubber tubing, I'm initially turning it using a parting tool, but when I part it off I'm using a chamfer tool, which means the end of the part, when it falls into the chip tray, will not be flat, it will have like a cone shape on it. And after the part is cleaned and polished, it will be fine for accepting the silicone rubber tubing. I want to use an O-ring on the end of this part, so it won't have to be tightened up into the hole, just screwed in by hand like this. I've fitted a copper washer, but I'm going to make this permanent. The washer is going to be fitted to the part using some Loctite 603, and after this is cured, the copper washer will be a permanent fixture to the brass fitting. I'm applying some lubricating oil to the thread in the hole. When I screw the part in place, it's a watertight fit. Or at least I think it is. Here I'm testing it by pouring some water into the drainage sump. The water doesn't go down quite far enough in the drainage sump. When I tip the baseboard, more water comes out of the fitting. What I'm doing here is enlarging the internal diameter of the piece of pipe that goes from the outer edge of the baseboard to the drainage sump. Now the sump and the pipe are full of brass chippings. That's an easy fix though, I'm just blowing them away with my airline. Time for a second test to see if it's made any difference. I'm putting the fitting back in position, and as you can see it's only finger tight. And now when I pour some water into the drainage sump, a little bit more comes out. You have to remember though that on the end of this fitting will be a long length of silicone rubber tubing down into a suitable receptacle on the floor. This will have a siphon effect that should drain the sump entirely. The last thing to do is to remove the fitting and put it in the plastic box. That's it for this episode. Stay safe, stay healthy. Thanks for watching, and I hope you found it useful. Please take the time to visit my Mainsteam Models website and click on the section of the website that says Video Playlists. And by doing that, you can find other videos that you may like to watch. And by using the playlists, you can actually watch the videos back to back.